using augmented reality to build NASA's newest manned exploration vehicle. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Shelley Peterson, Emerging Technologies Lead, Principal Investigator for AR and MR at Lockheed Martin. Welcome, Shelley.
Thank you. It's a pleasure to be here.
Now, you've been at Lockheed Martin for 6 years now. In what areas have you worked exactly?
I've worked in several areas. When I first hired on with Lockheed, I worked as a mission ops analyst on SBIRS, on space-based infrared systems. I've worked with business development and strategic ops analysis. And about 6 years ago, I started this effort with augmented reality and mixed reality and looking at how those solutions could benefit Lockheed.
Most recently, as you pointed out, you have been working on augmented reality to help engineers prove manufacturing processes on spacecraft. So what makes a one-of-a-kind product manufacturing such a great use for AR?
Our technicians are often building a spacecraft for the first time. You know, it's the technicians are very seasoned, very skilled, but it's the first time they've worked on that specific activity. So it's a learning process in almost every environment. And augmented reality has proven to be a fantastic tool to be able to relay that information very quickly without the need for interpretation.
The Orion spacecraft is NASA's next generation manned exploration vehicle. Tell us about your work using AR to help build Orion.
Sure. So we started off with drilling and torque applications where there's a complex torque sequence, and we need the technicians to understand the type of fastener, the type of the tolerance levels. They can capture all of this data from text and drawings, but it takes time to mentally translate that data to the hardware. So with augmented reality, you put on the device and you see that data floating in space right where you need it, when you need it. The beauty of it is also that we can build that content ahead of time before the hardware is on the floor and have quality approve it, have everything in place once it's available for the technicians.
You've chosen, I believe, Microsoft's HoloLens headset for the Orion project. What is it about the HoloLens that made you choose that specific device?
It's a true AR mixed reality device where content is hovering in place. It understands the environment, and it also has nice positional alignment. So when we're needing to place or mark the locations of objects within, say, a half an inch, it gives us that resolution to be able to pursue those use cases as well. And it also gives us occlusion where you can see through, or the effect of seeing through the surface to what would be behind. With the depth sensors, that's key for some of our use cases.
So what's it like using augmented reality in manufacturing process? How do the engineers like it? What challenges have you had to address since launching?
You know, they're our closest allies. The technicians guide us in where we can see the greatest benefit. And they help us understand where there's time delays in the traditional methods and where augmented reality might be able to help. So at first, we were wondering how they would receive using the HoloLens, but we take activities that take normally 5 to 7 technicians and complete the task with 1 or 2. We recently performed an activity where we were marking the locations of clip bonds, a fastener on the surface of spacecraft adapter jettison panels. And it normally takes 2 to 3 technicians, 2 to 3 days. But with augmented reality, 1 technician puts on the visor and completed the task in 2.5 hours. So that's a 93% reduction in just that one activity alone.
Those are huge, significant savings,
Right.
as well as accuracy and quality control.
Right.
So what kind of impact did that have on maybe your reporting directors or managers? I mean, what kind of support have they put behind using this, or maybe launching this throughout on more products?
Well, there's significant support. There's great interest. There's some things that we need to do in order to scale and to have it where it can be easily transitioned to manufacturing engineers to build the content and for the technicians to use. But we've developed a roadmap that leads us to that solution. And we're in the controlled and production stages of the technology moving toward that direction.
What do you see some of your biggest hurdles moving forward? You mentioned some of the operational things to put this in place. What do you think is your biggest challenge?
For us in Lockheed, we need to be able to secure the data. It's critical that we're able to control the use and secure the data, given our pursuits and our customers. So that's an area where we are often shaping the technology to meet those requirements.
Have you thought about using any other tools besides the HoloLens? Are you exploring other avenues in the space of VAR and VR?
Sure, we look at, definitely devices along with the HoloLens. Many of the devices that are available, we've piloted, along with information glancing devices. We also look at technologies that benefit our environments, like modulated light in place of Wi-Fi, eye tracking, EEG sensing. So different technologies that could lead to a more seamless user interface.
Thank you so much, Shelley Peterson, Emerging Technologies Lead Principal Investigators for AR at Lockheed Martin. You guys are doing some interesting work. Thanks for shedding some light on that. If somebody wants to connect with you and find out more about that work, how can they do that?
My email address, Shelley Peterson, or shelley.peterson@lmco.com.
Sounds good. Thanks so much. And if you guys want to find more of my interviews, you can do that right here on ZDNet or Tech Republic, or go to my website, tonyahall.net. I've got links to all my social sites. Thanks for watching.